how matching procedures can be used, or can be problematic for non-equivalent control group designs. The example that we used for this one was the study looking at reading performance. And let me pull this one up because that was kind of a complex idea.
I thought we did the one about studying or study that.
What's that?
I don't know.
So it was, yeah, I think this is the one I was talking about. Yeah, so we said that we used this example of looking at non-equivalent control groups. So you've got a group of disadvantaged youth from Greenville and then another similar group from Greensboro. And you've matched them up at the beginning of the study on their initial reading scores. So we gave a pretest to see what their reading skills were like, and then we selected participants who had similar pretest scores in Greenville and in Greensboro. But the problem that we mentioned was, let's see, your results might look like this, where they're equivalent on the pretest. So it has both had 25% reading efficiency on the pretest, but the Greenville group that actually received the treatment didn't change when you looked at the post-test scores. The Greensboro group that didn't receive the treatment actually increased. You said, why in the world would that be? What's wrong with that? And oops, I think I just put in an extra slide there. And so what we said was this might be regression to the mean that we're seeing. So of the Greenville children who took that pretest, they might have just had a really low average. So we selected children that did better than we would have expected, right? So they did exceptionally well for their group, for the pretest. Right? And so regression to the mean says that we can just expect that when somebody does really well on a pretest, that they won't do quite as well on the post-test. Right? They'll go back closer to that group mean. And we might have seen the reverse in the Greensboro children. So on average, their scores are usually higher than the children from Greenville. And so we selected children that did pretty poorly to get that 25% score range. Right? And so regression to the mean suggests that if they did exceptionally poorly, then they should do a little bit better the second time around. Right? And so if you go back to that result, maybe the treatment was actually effective, because if regression to the mean is what's going on here, and these people's average score before should have been about 17%, then you would have expected this to drop, but it didn't, possibly because of the reading program. And you saw this increase because of the fact that they did exceptionally poorly on the pretest, and so they regressed to the mean and did a little bit better on the post-test. So the whole idea there is that using matching for regression, for a non-equivalent group study like this, can be a dangerous thing to do. Okay. Where were we? We'll zoom in a little bit on this. Right. This is important. It's pretty fundamental. Based on a description of an experiment, be able to identify the design that was used. So I'll have some descriptions of experiments, just like we had on the last test. Although I know that people said those were tough, so I hope that these are relatively clear. I try to make them as clear as I can. So be able to determine if they're using non-equivalent control groups, interrupted time series. Remember, interrupted time series is when you're doing multiple pre-tests, and then you give a treatment, and then you do multiple post-tests. And then we talked about some variations on those designs. So just make sure that you're able to pick out what's being used, and also to interpret the results of those designs. And we went over examples of each one of these in class, so you should be able to review your old notes on these designs and then apply them on the exam. So, were there any specifics that people wanted me to go over from those designs? Variations on the basic time series design. I think that one was a reading assignment that I gave you, that we didn't actually go over this in class, but I said make sure that you read these pages. There's some variations on the basic time series design, so just make sure that you've done those readings. Let me look and see exactly what pages those were. That was supposed to be over. Oh yeah. Nope, that's not equivalent control group designs. Remember that nastiness? Okay. Oh, it was in here somewhere. Yeah. So 398 to 401. Just no, wait, that was something else. This is chapter 10. Yeah. But anyway, yeah, just make sure that if we don't have that in the notes, you go over it in the textbook. Problems that can occur when conducting archival research. So I think one of the key problems with archival research is you might have a limited selection of data. So you don't necessarily have access to all of the information that you could possibly use throughout history. And so the garbage in, garbage out principle applies to archival research. If you're using poor archival data, then you're not going to come to good conclusions. Let me just take a peek here and see what else you have to know on that. Case studies. Let's see. And then one of the advantages of archival data is you don't have to worry about the subjects reacting to the influence of the experimenters. So we had talked about problems like the Hawthorne effect, where people behave differently because they know they're in an experiment. Well, with archival data, you hadn't even formulated your hypotheses when these measurements took place, so that's not really an issue. But yeah, missing data and non-representative data, problems with that archival data itself do tend to be the biggest issues. But the biases of the experimenter don't tend to be a problem with that. So what else do we have here? The different types of programs, evaluations, that was pretty straightforward. The needs analysis just says, and these are for those like social programs to help people develop better health practices, for example. The needs analysis determines, is there actually a need for this program? Formative analysis is done once the program has just begun, and the question is it being implemented correctly? Summative analysis was, well, now that the program has been applied, did it actually work? And then the cost effectiveness analysis is, are the benefits provided by this treatment actually, do they justify the cost? Okay. So, and if you're comparing similar treatments that have different costs, how do those compare to one another? You're basically just doing cost-benefit analysis there. So any questions about the Chapter 10 stuff? Yeah?
What did you say?
Formative, that's when a program has been underway for a short period of time. You can look to see if it's working in the short term and if it's being implemented as originally planned. So it might be that it's a good program, it's just that people aren't following the instructions that were part of the original design. And so that the formative analysis would determine that that needs to be changed if the program is actually going to have a chance at being effective. So it's essentially like a, let's see, so you start giving the treatment and then you check in at an early stage and just see if everything's going okay. That's what the formative analysis is. It's that preliminary checking in. Small N designs. Fortunately, these last couple of chapters were a little bit easier, I think. So we talked about some historical small N designs, and you'll just need to know about the different studies that we talked about in class. There was Dressler's study on facial vision, remember, where there were the different materials that they wanted to see if people could detect the difference between a solid wood panel and a lattice in front of their face, even though their eyes were closed. And they only had like 3 participants for that, and one of the participants was the researcher. Let's see. Forster and Skinner's work on schedules of reinforcement. Remember, we talked one day about the different schedules of reinforcement, the variable and ratio schedules of reinforcement and all that, or variable ratio and variable interval, fixed ratio, fixed interval. So you should know those, and remember their results were presented using one of those cumulative recorders. Remember I brought in that big old piece of equipment? And so when you look at the results from those studies, what you're seeing is the results from one subject. So if this was done with a pigeon, you'd see this long line that would change at a certain rate, or you'd see the behaviors indicated on that line. And that's all the behavior of one individual, right? So that's very characteristic of those old small N studies, looking at the behavior of one subject in great detail. Let's see. Then you just need to know some of the details about all those other studies that we talked about. We obviously don't have time to go over each one of those individually in our review session, but you should hopefully have notes about those, and all of those are in your textbook as well. What is the function of using additional subjects in small N research?
Increase your amount of data and have better results. Or better opportunity of having accurate, coming to accurate conclusions.
So that's true, but it's actually more true for the large N designs. With the small N research, the idea is that the behavior of one individual is sufficient, but additional participants are used for the purposes of replication. So with Skinner's work, for example, they might use one pigeon for a lot of the research and then just switch out with a different pigeon to see if they get the same pattern of results. It's a replication function. Research on discrimination learning in children and what it reveals about the utility of small N designs. So let me put that slide up real quick, because I thought that one was especially neat, and it's really important to understand this. So we said that if you looked at grouped data for learning, it would look like learning occurs gradually. There's this gradual slope. But if you look at the data for an individual child, it looks very different. It looks like there is some distinct point at which they go from not understanding to understanding pretty well. And the reason you see that difference is that, let's see. With the group study, you're looking at the average of a number of different individuals. And people learn at different rates. So some people learn quickly, some people learn slowly. And so when you plot the line that is that average, it looks like this. But that isn't necessarily true for the individual subject. You wouldn't want to say that learning occurs gradually in individual people. It occurs, at a specific point, right? But if you're looking at group learning, groups learn gradually because they're made up of a bunch of individuals who each learn at their own rate. Right? But what is true for the group isn't necessarily true for the individual. And so we talked about this individual subject validity. That's another thing that was on the study guide that you'll need to know about.